Hi everyone, so this video is going to be about theoretical probability. So theoretical probability assumes that each of the outcomes of a particular experiment are equally likely, and this is really important. So provided that you're completing a probability experiment and all of the outcomes are equally likely, then we can start with this formula to piece together our theoretical probability of something happening. So the probability of a given event happening is a fraction created with the numerator being the number of outcomes in E, and then the denominator is the total number of possible outcomes. So let's walk through a really simple example. So we'll talk about rolling a die. So we're assuming this is a normal die and the sides are 1, 2, 3, 4, 5, 6. Now assuming regular, everyday, nothing fancy, nothing special die, each of those outcomes are equally likely when we roll, even if it doesn't seem that way sometimes when you're playing a game and need to roll a particular number. But if we wanted to figure out the probability of rolling a 5, for example, then we look at the total number of outcomes in E. So how many of the outcomes are the one that we want, which is rolling a 5? And the answer is one of those is the outcome that we are after. Out of how many possible outcomes altogether? So out of 6. So the theoretical probability of rolling a 5 is 1 out of 6. If we were to expand that and say the probability of rolling an even number, well, then we would look at the numerator being the number of outcomes that are even. So we have 2, 4, and 6 are all even. So we have 3 outcomes that are in the event that we are after, which is even numbers. And then the total number of outcomes is still 6. So we would generally reduce that to be 1/2. So lowest terms is kind of the name of the game when it comes to fractions. Okay, so let's walk through a couple of examples of this. So in this first example, we have a ticket randomly selected from a basket, and that basket contains 3 green, 4 yellow, and 5 blue tickets. So we're going to determine the probability of getting, and then we have a different assortment of possibilities. So the first thing that we're going to want to do, once we recognize that each of these tickets has an equal chance of being drawn, then we're going to figure out the total outcomes. How many possible outcomes are there? Outcomes. So there are 3 green, there are 4 yellow, and there are 5 blue. So in total, we have 12 outcomes, and each of them are equally likely to take place. So in part A, we are working to figure out the probability of drawing out a green ticket. So we look at the number of green tickets in that basket, 3. The number of tickets altogether, 12. So the probability that we will draw a green ticket is 1 out of 4. Part B, we have green or yellow. So the number of green or yellow. So the number of green tickets is 3. The number of yellow tickets is 4. So our numerator will be 3 plus 4. And then our denominator is still the 12 tickets that we have in that basket. So the probability of drawing green or yellow is 7 out of 12. Part C, we're looking for the probability of an orange ticket being drawn out. We still have the 12 possible tickets inside the basket, but the problem is there is no orange. We have green, we have yellow, we have blue. So there are 0 orange tickets or 0 tickets that match the outcome we are looking for out of 12, so that is actually impossible. So that has a probability of 0, or it is an impossible event. Then part D, we have green, yellow, or blue. So green, yellow, or blue. So green tickets, 3. Yellow tickets, 4. Blue tickets, 5. Out of 12 tickets altogether, that gives us 12 out of 12, or a probability of 1. So this is what we would refer to as a certain event, and this is an impossible event. Okay, so let's go through a slightly more complicated example where we have two parts to our probability experiment. So in this scenario, we are tossing a coin and we are rolling a die. Those things are happening simultaneously. Well, you assume one right after the other, or maybe two people are doing them simultaneously. So the first thing it asks us to do is use a grid to illustrate the sample space. So sample space, remember, is all the possible outcomes that we could have. So on one axis, we will put the coin. Heads and tails are the possible outcomes for our coin. And then on the other axis, we will put the outcomes for the second part of our experiment, which is rolling the die. So we have rolling a 1, 2, 3, 4, 5, or 6. Then we'll draw lines up from each of those. And then we will put dots on to illustrate each possible outcome. And when you take all the possible outcomes together, you have all of the sample space. Okay, so then we're going to use our grid to help us determine some various probabilities. So in part B, first part, we are looking for the probability of tails and a 5. So we're going to go through and we're going to look at each of these possible outcomes and determine which of them are tails and a 5. And we see that there is only one outcome that matches what we want, where it gives us both tails and a 5. So that is one possible outcome out of the 12 that exist. The 12 dots represent each of the possible outcomes. There are 12 of them. One matches the specific criteria we were looking for, which is tails and a 5. In part 2, we are looking for heads and a number less than 3. So heads and a number that is less than 3. Okay, so we need heads and we need a number less than 3. Well, we've got this outcome is heads and a 1, which is less than 3. This outcome is heads and a 2, which is also less than 3. But if we look just exclusively at the heads outcomes, those are the only two that have a number less than 3. So to get this little tiny word and, we need both of those things to be true. So there are two outcomes out of the 12 that match the criteria that we're looking for, which is heads and less than 3. So we would reduce that to be 1/6. Okay, and then our final example question here, part 3, we want tails or a 5. So there are two really small words in probability that have big implications. One of them is the word and the other one is the word or. So when we're talking and, both things must have taken place. When you're talking or, you only need one or the other, or potentially both, but you need only definitely one, potentially both. So if we look at tails or a 5, that means we can have all of these outcomes fit the criteria of tails. And then there is one additional one here that also would fit the criteria. So all of these ones are the ones that have tails. And then this one additional one over here is the 5. So if we're looking at tails or a 5, any of those outcomes would fit. So we have the 6 outcomes that include tails, and then one additional that includes heads, but also has a 5. So then we have 7 out of 12 would be the probability for that particular scenario. Okay, so that covers how to find theoretical probability. So you're basically just building a fraction out of two pieces. The number of outcomes that exist in the event you are finding the probability of, and then the total number of possible outcomes. So build those two pieces of your fraction, reduce where you can, and that's it.